All right. John, can you just confirm real quick that you can see and hear me?
I can see and hear you, and everyone should be seeing my slides as well. We are good.
Um, okay, I'll go ahead and get started then. I'm sure we'll have some people still trickling in, but I'm just going to do a short introduction to who Fierce Software is before John goes ahead and gets started. I think most of you, since you're all Raytheon, probably know who Fierce Software is, but just in case, I'll just do a brief introduction on who we are, what we're doing on this webinar and partnering with Red Hat. So Pure Software, we are a value-added reseller of open source technology. So obviously Red Hat being one of our largest partners on the DevSecOps side, we love working with them, especially with the training team here with John, Alex, and Justin. And today, specifically for Raytheon, this is an event that we're putting on for you guys, being one of our largest customers in the public sector, community. We do a lot of work with you guys. So as a, value-added reseller, we like to put on these events to give back to our customers, help further your education with technology that you're either already using, planning on using, evaluating, so forth. So I'll introduce myself quickly. John will be doing all of the talking today, but just so you know who I am, my name's Elizabeth Glenzer. I cover Department of Defense and Special Missions here at Fierce Software. So, work with Raytheon on the day-to-day. So, obviously, if you guys need anything, feel free to reach out to Fierce or Red Hat, and we'd be more than happy to help you out. But I will go ahead and let John get started. I know that this is always a really well-received webinar and super helpful for people, so it should be same today. If you guys have any questions, feel free to drop them in the chat, and we'll be monitoring those and maybe interrupt John for a second if needed to get some questions answered. But without further ado, I will let John get started.
Awesome, thanks, Lizzie. So again, I'm John Walter. I'm a solutions architect here at Red Hat. I currently work with the training certification team, covering all of North America. So I work a lot with our partners as well as system integrators with our customers to help develop different training solutions and plans for them. Today we're going to be talking about Kubernetes and really kind of Kubernetes as an underlying platform for our OpenShift container platform. We'll start off taking a look at the agenda. Just kind of a high-level overview, right? We're going to start really at the smallest unit with containers, right? Why are organizations, why really is the industry starting to move more towards containerized workloads away from more monolithic applications on data centers? From there, we'll move towards, broadening, what is Kubernetes, right? What is container orchestration? Why do we need a tool to help us to manage these containers? And then from there, we'll move into OpenShift, right? And OpenShift is our really enterprise Kubernetes platform. We will spend a little bit of time talking about some of the training and certification options that you have with Red Hat. And then we will have time for Q&A at the end. There is a Q&A tab there. Feel free to drop questions throughout the session in the Q&A or within the chat. If Lizzie and Eric and folks on my team are going to be monitoring that throughout. So, for them, feel free to interrupt, as Lizzie said, if there's definitely a relevant question. Otherwise, if you have, some kind of one-off questions, we want to hear from those as well. So feel free to drop those into the chat. So without further ado, let's jump into it. So what is a container? So hopefully this isn't totally brand new information. If it is, it makes sense you showed up to the 101 session. But, I think before we dive really into, the technical aspects of containers and what the benefits bring, maybe we should take a step back and talk a little bit more around digital transformation, which, for those that are on the call that are from Red Hat who have worked with me, that digital transformation is the one term that makes me roll my eyes every single time that I hear it. And yet I continue to talk about it. And a big reason of that is because, digital transformation, as cheesy as the term it is, as I think annoying as it is to a lot of the people that are actually doing the things that require digital transformation, it is really a good kind of indication as to the direction that a lot of organizations are going, right? And when we talk about digital transformation, we're really talking about how do we become a better software company, right? How do we change our development practices, right? So what you're seeing here on this on the slide are really on the left side, the way that things have been, and on the right side, really the way things are moving towards. And so you're going to see things like changing or moving away from a waterfall development cycle towards the ICD. You're going to see, organizations, and you guys are probably helping a lot of these organizations, moving away from deploying into data centers. They want to deploy to the cloud, and maybe that's with a single cloud provider. Maybe that's across multiple public cloud providers. Maybe that's some kind of combination of a public and private cloud. What we're talking about at Red Hat a lot, and what our parent company IBM is really talking about a lot is now the hybrid cloud, the multi-hybrid cloud. And so that's really where our focus is. And the goals of each of these steps, moving away from virtual machines towards the cloud, moving away from monolithic applications towards more microservices, all of these different steps, really the goals of these steps should be to focus on the business outcomes, right? We want to increase speed, agility, and control. And those three components, speed meaning, how quickly we can deploy new ideas. Agility meaning, when we look at the context of updates, right? How can changes be made more simply and more efficiently, and also provide, room for more experimentation, more innovation. And then control is, how do we mitigate the risks and security and issues and then approach those in a more quick way? And so a lot of this goes back to, a term that's been within the industry for as long as I've been working within tech, the last 10 years or so, agile integration, right? And so it's all around defining a new method for integration, right? We need our applications, even the way that we're approaching the design of those applications, to be more agile. They need to be more scalable. They have to exist across, various public, private, hybrid clouds, and ultimately to be able to iterate more quickly and more efficiently. And so, what you see here is a more traditional enterprise service bus. On the right side, you see really a more modular look at the modern architectures, right? And this is what's enabling organizations to move more towards, artificial intelligence and machine learning, and obviously IoT, which has been, a really major use case, I would say, in the last, 7-8 years. This is why our applications and where those applications are running, all of this has to be more agile. And so that's really where containers come into play. And so, when I'm speaking to customers, and they're just starting along this kind of container adoption journey, a lot of the questions I get are like, what is a container, right? And the answer really depends on what audience is asking, right? When an infrastructure team is asking what a container is, we can talk about their application processes on a shared kernel, right? It's providing the same application, but without all of the overhead of spinning up a virtual machine and having that application run on those dedicated virtual machines. So they're portable, right? They should run the same way on any environment. When you ask an application developer what a container is, that's when we get more into, well, it's all about packaging the binary with the dependencies and making sure that, this application is running the same way no matter where it's being deployed, right? It's something that can be deployed really, really quickly. It's something that likely as an application developer, I can deploy onto that infrastructure no matter where it is, whereas having to hand over responsibility of actual deploying that application to the infrastructure team. And so we'll talk a little bit about this in a second, but a lot of this comes down to DevOps, right? And we'll talk a lot about how, the proliferation of container adoption has really coincided with DevOps adoption as well. But, stepping back towards, the first part of this slide, when speaking to the infrastructure teams, I really want to highlight, and we'll do this in the next few slides, a lot of our customers are now kind of facing a dilemma between, we have all of these workloads across multiple virtual machines. Do we really need to go through all of this work of migrating these application workloads away from virtual machines and towards some kind of container platform? And what are the perceived benefits of this? So I want to break those down really quickly, and then we'll kind of move more into the Kubernetes piece. But excuse me. But traditionally, our customers they're co-locating these applications typically on a single virtual machine, right? And this is largely due to operational overhead, the amount of resources available, the costs associated with all those resources, whether it be the actual compute piece or even just the staffing, right? Price is a big component as to why virtual machines have been so prolific over the last 20 years or so, right? And while virtual machines are isolated from each other, the applications that are co-located on those virtual machines, they typically don't have a lot of isolation from each other, right? They could potentially negatively impact each other, whether it be their underlying files or their configurations, the behavior of the applications. Meanwhile, on the right side there, you have what a traditional Linux container looks like, right? So a Linux container is sharing the same host, so that's the kernel when we talk about Linux. At the same time, it's able to leverage a lot of these different underlying kernel technologies, so things like SE-Linux or namespaces or control groups, and all of this to provide isolation so that one container can't access another container that's running on the same host. It also can't access the underlying host itself. And so, Linux containers in a way are a virtualization technology. You have your virtual machines that are there for virtualizing the actual hardware, where containers are more for actually virtualizing the application processes, no matter where they're running. So, with the hardware, the hypervisor piece, with virtual machines, typically, depending on the virtual machine, hypervisor may be very, very important, very specific. Whereas with containers, the hypervisor could be, OpenShift. It could be just vanilla Kubernetes. It could be Docker. But ideally, in theory, the container, no matter where it's running and what hardware or infrastructure or the hypervisor is sitting on top of, the behavior of the container shouldn't change at all. And so, it's possible you could run every application on a single virtual machine. The operational overhead, the resources costs of all of these different virtual machines that you would need to run typically is going to invalidate any of the perceived benefits for that. VMs have the advantage of providing that hypervisor level isolation for the application, but that comes at the cost of having to run a complete operating system for each application. And that's, intensive on memory, that's intensive on your CPU. And VM's compute and memory capacity is all predefined. So it's not super easy. It doesn't provide a lot of elasticity or bursting, which we'll talk about a little bit later on. It doesn't really allow for more bursting when an application requires more memory, requires more CPU power. Whereas, containers are providing the isolation through taking advantage of those kernel technologies we talked about before, all of which have really been battle tested and used for years. I mean, SE-Linux, for instance, that's something that was developed largely by the DoD, and Google, I think, was a large contributor to that as well. That's been a part of Linux and Red Hat Enterprise Linux specifically for over 10 years at this point, right? So these are technologies that a lot of the organizations that are going to be moving towards containers, a big kind of struggle for them is we can't just start from scratch, right? And so there are technologies there that their system administrators are already going to be familiar with. So they're not really having to start from scratch, right? They're going to have to learn about containers. They're going to have to learn about Kubernetes and potentially OpenShift. But all of the technology underlying is all extremely familiar to them. So they're going to understand the benefits really, really quickly. They're going to understand how to, say, secure the platform, because securing the platform is the exact same as securing their Linux deployments as well. And so since those containers, they're using a shared kernel and that container host, it reduces the amount of resources that are required for the containers themselves. It's a lot more lightweight than a virtual machine, and it provides kind of an agility that's just not really feasible with VMs. For instance, it takes a second to spin up, let's say, a MySQL container image, right? But if I wanted to spin up a MySQL application on a virtual machine, and I don't have that virtual machine provisioned already, well, then I gotta, maybe wait 5, 10, 15 minutes to, let's say, Pixie boot a new VM, and then I have to install that application. It takes a lot more time, whereas I can, with the click of a button, spin up a container really, really easily just from this standardized image, which we'll talk about in just a little bit. And so, I said this before, but DevOps adoption really skyrocketed in the last few years, right? DevOps has been something that's been talked about for really 10 or so years, and before that, Agile and these different operations, these different practices were all around. But DevOps has really, really blown up, I would say, probably in the last 5 years or so. And the fact it's not a coincidence that container adoption is playing a really important role in enabling these organizations to implement DevOps without a lot of the obstacles that they faced before. And a lot of that was obstacles with virtual machine based deployments and even before that. And so, when we talk about VMs as the unit of compute, right? Applications, they're developed by the development team, the result of which is then delivered as some arbitrary package, which typically is going to vary between the teams. It's going to vary between the applications. There's not a standardized way of delivering that arbitrary application to the IT ops teams, and that IT ops team is now responsible for building and deploying and managing that underlying hardware or maybe virtualized hardware. So in this case, we'll talk about virtual machines, right? And so they have to manage the virtual machine. They have to manage the operating system, the libraries, the application dependencies, and the application itself, right? The IT ops teams are managing all of the components of the infrastructure as well as all of the components now of the application, right? So this can create a really conflicting atmosphere between the dev teams, between the ops teams, and any other teams that are involved in delivering the application, because now you have the ops teams, they're forced into ownership of a potentially undocumented or non-standard layer of their technology stack. And they're typically not familiar with it. They're having to rely on instructions from the development teams. Potentially they are very thorough, potentially they are non-existent, right? And so that is a major, major issue with a clear delineation of responsibilities across the application lifecycle. When you look at containers, use containers as a unit of compute, there's really a clear boundary between the layers of the technology stack that the operations teams and the development teams are owning and managing. You have your dev teams, they're deeply familiar with the application. They build, along with any of the dependencies and the configurations of the application, they understand that backwards and forwards, right? So with containers, they own the application, they own its configuration, they own the package, and they package that, as a result, we create a container image, right? So this is a standardized image, the contents of which are obviously going to be very different between container to container, but a containerized image is a standardized format that you can then, as the dev team, hand over to the ops team. It's a standard package, regardless of the technologies that are actually used to build the container or build the application. So the ops team doesn't care what those underlying dependencies are, because those underlying dependencies are packaged within the actual container itself. So now you've delivered this standardized format to the IT team, or the ops team. They own the entire infrastructure, right? So they own the container host, they own the virtualization layer, they own any other thing that sits underneath the application, and so they're providing an environment for running these standardized container images, and they can deploy and monitor and manage those containers across whatever infrastructure they have at their disposal using really standardized procedures, and they don't have to have they don't have to adapt those procedures, with every application that comes their way, right? And so, I've worked a lot with customers who they have multiple development teams who are, building out different kinds of applications, and some of those development teams may be building Java, let's say Java 8 applications. Some may be building Java 7 applications. Some are building Python 2.4 applications. Some are building Python 3.5 applications, right? And so traditionally, you would probably need infrastructure for each one of those applications, or you would need an OS and the OS dependencies separated out for each of those different applications, because the runtimes, the versions that those applications have been compiled on, all of those things are conflicting. And so with containers, we don't really care what the dependencies of the actual application are, because that's all built in with the actual container itself. And so now I can run multiple versions of an application with different runtimes and different versions of whatever underlying pieces, and I can have those all running on the same underlying infrastructure, which is really, really great. And so by using containers, your dev, your ops teams, they can work at different speeds. They can upgrade and downgrade, the servers or the actual applications independently of each other. And they can move applications between these different environments and expect that the application is going to perform seamlessly and identically across the different underlying environments. And so, there's a clear ownership boundary here between the dev and ops teams. They're able to really work seamlessly during the application delivery cycles, and it lays the groundwork for enabling DevOps across the organization. So there have been a lot of efforts to standardize, the virtual machine format. It never really succeeded, right? If you're a VMware shop, the VMs on premise are tied to vSphere. If you have virtual machines running in the public cloud like AWS, they're tied to AWS hypervisors. And so, moving applications to other infrastructure, if you want to move that application away from a virtualized infrastructure towards bare metal, let's say, or towards the private cloud, it typically would require rebuilding the application and maybe even the entire stack from scratch, right? Based on the chosen infrastructure. You have to do all these re-verify, on the previous infrastructure, et cetera. And so, we're trying as an industry really to move more towards immutable infrastructure. We're trying to simplify deployment, simplify management of the actual software as well. And so that is really kind of in a nutshell why we're trying to move away from virtual machines and move towards more containerized workloads, application portability. And so, that's what you're seeing here, right? Containers that are providing the application portability, partly due to that standard image format and the fact that they're really only dependent on Linux. And that's in the contents of Linux containers, which is, the overwhelming majority of containers that are out there. And so, this gives teams better control over the infrastructure that they're, deploying the applications on. And a container host provides a common ground for running those containers on any infrastructure, whether it's your laptop. I have something called code-ready containers, which is something that's free to everyone. You can get it through Red Hat for free, developers.redhat.com if you want to start playing with, deploying essentially a lightweight version of OpenShift on your laptop. So, I use that a lot for like my test environment. So I've got containers running on my laptop right now. Obviously, if I wanted to move that same containerized workload to AWS, in theory, I should just be able to make a copy of that container image, spin it up on AWS, probably pay a lot of money to get AWS access. But, nevertheless, the portability is really key, but portability doesn't guarantee compatibility, right? You still have to build these applications for whatever the underlying architecture is, right? And so, a 64-bit application isn't going to run on a 32-bit hardware. When the container image is run, the binaries inside the image, they run just like they would normally on a Linux OS. And so there has to be compatibility between the container image and the container host. But more often than not, you're going to be building just, let's say, 64-bit binaries, just 32-bit binaries. So that shouldn't be too much of an issue. But those kind of inconsistencies, they can range from sporadic failure, which is near impossible to try to debug, to complete failure, right, where the container just isn't going to run at all. Those incompatibilities, they can lead to performance degradation, security issues, and so it's not completely absolute, the portability of these Linux containers, right? Some of our customers are using different Linux distributions in conjunction with RHEL. Maybe they're using extremely different versions of RHEL, right? We still have, and I'm sure you all work within, working with our public sector customers, understand that, some teams are starting to play with RHEL 8 right now, whereas some are struggling to move away from RHEL 5, which is at this point like 15 years old. So, having those widely differing versions can lead to some serious problems. So in order to guarantee portability, compatibility, it's a best practice to run, a consistent version and distribution of Linux in all the containers and on all the container hosts across the environment. So, this is pretty much the surefire way of guaranteeing compatibility. And whether it be horizontally or vertically. Immutability also is one of the key benefits here with these container images, right? Without being tied to a specific machine image format like you are with virtual machine images, like there's AMI on AWS, right? And so now you're seeing organizations, Netflix did a session at Red Hat Summit last year where they talked all about basically that they were at this kind of inflection point where containers weren't quite mature enough for them to start adopting that. So they completely moved towards all their workflows towards virtual machines. And they've realized, and since then moved now towards OpenShift. And they said, we're adopting containers to really enable the same kind of continuous delivery workflows, but now it's in a much more portable and efficient manner away from virtual machines. So you probably heard this before, containers are Linux. This is actually, now I'm realizing, kind of an old slide because the statistics have actually gone quite up. But obviously, Red Hat Enterprise Linux is the leader in paid Linux, and an overwhelming majority of containers are Linux containers. And so, from a customer point of view, obviously there is a significant amount of enablement that has to happen around building up knowledge share of containers, and we'll get into Kubernetes, we'll get into OpenShift in just a bit, but everything underneath that, and even within the containers and with the container host itself, are Linux, right? And so, teams who have mature Linux ecosystems within their environments, they're able to really have a leg up over customers who are, let's say, Windows shops who are now starting to, kind of play around with something like OpenShift, where they're now having to learn the Linux skill sets and the container Kubernetes OpenShift skill sets, whereas a lot of our customers who have been really embedded in the RHEL ecosystem are kind of getting to hit the ground running, so to speak, a little bit more quickly. So to recap, containers in a nutshell. I'll speed through this. I know I spent a lot of time on these first few slides, but really containers are transforming the way that we think about application architecture, about the way and the speed at which teams can deliver on different business requirements. And really, containers, they promise the application portability across the hybrid cloud environments. They allow developers to really just spend time focusing on building their applications instead of having to worry about any of the execution details, any of the underlying infrastructure. And while containers are removing complexity through minimalism, managing container deployments is a new challenge for these IT operations teams. Containers, they're deployed for a lot shorter periods of time than most virtual machines are going to be, right? Typically, those containers are going to have greater utilization on the underlying resources. And related container technologies, they have to manage way more objects with a lot more turnover. So this introduces the need for automated policy-driven management. And so that's why teams are starting to turn towards Kubernetes, right? Kubernetes, it provides a rich set of features that will help them to orchestrate and manage those containers across their entire lifecycle environment. And Kubernetes itself has really emerged kind of as the de facto standard for container orchestration and for container management. It's really become a critical platform for organizations to understand. So what is Kubernetes? And I say this every time I present this slide. This is my favorite slide. I just love seeing the somehow I manage image there. But containers are popular because they allow that application to run that isolated process with its own resources, right? It's a lightweight nature. It means each application, it gets its own container. It prevents those dependency conflicts we talked about before. And so in this context, let's just think of a container almost as like a zip file or tarball or something like that, right? So it's a way of bundling the code, the configuration, the dependencies, and it eliminates any kind of issues with, hey, it worked in my environment, why didn't it work in your environment? And as we start to move more towards applications being really just discrete functional parts, each of which that can be delivered in a container, it means that for every application, there are now more and more parts to manage. Containers have shorter lifespans than a traditional VM. The complexity of managing those applications with all these objects, all of this churn, it introduces new challenges. So, configuration, service discovery, load balancing, resource scaling, discovering and fixing failures. How do I manage all of this complexity, right? doing them manually would be impossible, especially at the enterprise scale, right? If you're running just one or two containers just for fun, you've got some media server that you've got configured at home, well, then you probably don't need Kubernetes. But if you're expecting to leverage containers to support enterprise workloads and production workloads and customer-facing workloads, you need something that is much more automated to manage all of this, right? Traditionally a cluster might run more than 1,000 containers, right? And so updating these clusters is really infeasible without automation. And so that's really where Kubernetes comes in. It delivers that production grade container orchestration by automating the container configuration. It simplifies scaling, and it manages those resources and how they're allocated. And so some of the benefits of Kubernetes, right? It can run anywhere. Whether you want your infrastructure to run on site, you want it on a public cloud, you leverage AWS, or a hybrid configuration of both, right? And the experience is identical, right? And so if your cluster, maybe you have this giant cluster and it is a mix of dedicated hardware that you have on-prem, maybe you have OpenStack running for your private cloud, and then you've got AWS over here for your public cloud. Kubernetes and the way that you interact with all of these three components is exactly the same. And so the experience from an operations perspective is identical. And so Kubernetes in a nutshell, when we talk about more complex applications that are consisting of all these components, containers, they vastly simplify the updates of these different components of each application. And so by placing each component in a container, it makes it really, really easy to make changes without having to worry about any of the ripple effects, right? And this simplicity has really led to containers becoming a great way to develop and deploy microservices. Microservices or applications with a single function, they really naturally benefit from containers because they provide a clean separation between components and services. And, there is, which we won't talk about here, but just as a quick aside, there are things out there, things like Istio, which is a project from IBM that is, really taken over as a way of creating a service mesh. And so we've just within the last year or so introduced something called Red Hat OpenShift Service Mesh, which is based on Istio and Jaeger and a couple other projects upstream as a way of building resilient microservices and then managing them, creating a control plane really to allow these different discrete functional parts to be able to communicate with each other, because that's certainly, sometimes, and I would say oftentimes, extremely necessary. So back to the Kubernetes piece. Kubernetes is an open source container orchestration platform, helps to manage these distributed and containerized applications at a massive scale. You tell Kubernetes where you want your software to run, the platform pretty much takes care of everything else. And so what else does Kubernetes provide? It provides a unified API to deploy, a web app or batch job or database. And these applications are packaged in containers. They're cleanly decoupled from the environment, and then it automates configuration of those applications. It maintains and tracks resource allocation. And it also presents so many more challenges for operations teams. So what do we mean by container orchestration? This essentially just means that Kubernetes is going to figure out where and how to run your container, and provides three primary functions. So the first, schedulers and scheduling, right? So schedulers intelligently compare the needs of a container with the health of your cluster, and they suggest where the containers might fit within the cluster. So think of a scheduler as a thermostat, right? So you tell your thermostat you want it to be 70 degrees in the house, you expect it to maintain that temperature, and the thermostat is just constantly checking the temperature, resolving against the setting. Hey, it's 71 degrees in the house, let me make sure I bring down the temperature. And so you set a temperature, the thermostat is trying to maintain that temperature on your behalf. Same way Kubernetes is seeking to maintain the cluster health on your behalf. So you're no longer having to kind of mine the proverbial temperature. You're now, as let's say a developer, able to just focus on building your application. As an operations team, you're worried or really primarily focused on just putting out fires or maybe scaling the cluster. Whereas previously you had to worry about where these applications were sitting. You were having to worry so much more about is the application running correctly? Do I need to scale? Do I need to bring it back down? The second piece, service discovery and load balancing. So in any system, service discovery can be a really big challenge, and Kubernetes is not an exception. The more services that make up your application, the more difficult your application becomes to track and to manage. And so thankfully, Kubernetes automatically manages a lot of this service discovery. So you might ask Kubernetes to run a service like a RESTful API or a database, something like that. And Kubernetes is then taking notes about these services, and it can return a list as if we ask about it later. So it takes note of all these different components, and it also checks the health of the individual services. If it detects a crash in the service, it might attempt to just restart it. If it notices that it's crashing significantly, it might kill that service and spin up a new one in its place, right? And so let's say you have maybe Kubernetes detects a crash in the service. It'll automatically attempt to restart it, but it also allows for more subtle health checks, right? So maybe you have a database and it's not crashed, but it's just performing really, really slowly. So Kubernetes can track that, and it can direct it to one of these backups if it detects that slowness. And then it also incorporates load balancing, right? So modern services, they're scaling horizontally, right, by duplicating services. And so the load balancer is really the key piece that distributes and coordinates the traffic across these duplicates. And so it makes it really easy to incorporate a custom load balancing solution like an HA proxy or cloud provided load balancers. AWS offers one, Microsoft Azure offers one. We offer one as part of our private cloud OpenStack as well. And then the third component is around resource management. Every computer has a limited amount of CPU, power, memory. And so, maybe an application that you're running, it transcodes video. So that's going to be really CPU bound. Or maybe you have an application that's parsing text that's going to be really memory bound. And so this means that, that video parsing or processing application, transcoding video application, that's the example I used, it's going to run out of CPU first, right? Whereas the text parsing application is going to run out of memory first. And completely running out of either of those is, a no-no. Can't let that happen, right? It's going to lead to probably the system crashing or at least being wildly unstable. And so Kubernetes is able to really properly manage these resources because of intelligent scheduling, which is what we were talking about at the very beginning, right? You're able to schedule those applications to appropriately use resources like CPU, like memory, while staying cautious about overutilization that can lead to system instability. I do see that there's a question real quick. I'm going to check that just before I move into the next slide. So with Kubernetes, there's no need for a separate network monitoring software. So good question. I will not answer it right this second because we're going to sort of touch on that in just a little bit. But I like where you're thinking. You're on the right track here. So some of the other benefits, and I'll kind of run through these really quickly, but scalability is a really, really big part of this. There's an auto scaler built into Kubernetes that will scale your cluster based on the needs. So that's not just scaling up, but scaling back down as well. So, especially thinking about this time of year, thinking of our, retail customers, this is a time where those clusters are probably scaled and they're staying scaled, right? I think back to the week, Black Friday used to be a single day, and then there's Black Friday and Cyber Monday, and now it seems like all of November is just sales. And so traffic for those sites is really, really increasing. And so, we want our clusters to dynamically scale to meet that demand. And so Kubernetes provides a cluster autoscaler. There's a horizontal pod autoscaler too. So this is talking about the actual underlying container orchestration host that's able to scale, and the individual applications running are able to automatically scale based on traffic as well. We've talked about portability as far as, Kubernetes being able to run anywhere, running on-site in your data center or in the private cloud, and that the commands that you're using to control and interact with the cluster are going to be identical no matter where it actually lives. Consistent deployments, right? Kubernetes deployments are meant to be consistent across infrastructure. We talked about that a lot earlier as well, right? We talked about immutable infrastructure. All the dependencies, the setup instructions that are required for that application to run are bundled with the containers. So, if you're not familiar with the pets versus cattle argument, this is really what we're talking about, right? Pets are, typically we think of our virtual machines or our our bare metal systems, our server racks, sort of as pets, right? We maintain them, we give them names, we know all their really strange nuances and all the different things that we had to do over the years to maintain and update. Whereas with containers, they're cattle, right? They're mass produced. They don't live around for a long time. There's no reason for me to have fear because they set themselves up the same way every single time. So if this application that's running over on this part of the cluster isn't scaling or isn't performing well, I can just burn that one down, spin one up over on this side of the cluster, and then boom, I'm back at it. So really it's about providing that consistent experience. It means that developers can spend a lot less time debugging, more time innovating or continuously integrating and deploying updates to those applications. The last piece that I'll talk about on the slide, separated and automated operations in development. So, it's really common for those ops teams and development teams, as we talked about before, to be in contention because ops teams value stability, right? They're more conservative about change, whereas dev teams typically value innovation. They prize a high change velocity. And so Kubernetes is sort of designed to resolve that conflict, right? There's intelligence and automation that's built into Kubernetes so that operations teams can feel confident about the stability of the underlying system, whereas containers are also saving developers time, right? So they empower the developers to have rapid iteration cycles, to try to innovate, to build on new features into these applications. So, and this is where we sort of transition into a really good question there around the networking piece. Kubernetes is software for managing containerized applications on a cluster of servers, right? These servers, are typically what we used to call kind of the master worker nodes. We're now referring to as control plane and worker nodes, but essentially the control plane is the equivalent to the concept of what we would call the master node, right? It acts as the brain of the cluster. This is where, scheduling and service discovery and load balancing and resource management, all those capabilities we talked about earlier, they're all provided by the control plane, right? So, here you're seeing a very, very rudimentary, high-level architecture view of this. We're not going to get into a lot of the details, a lot of these different functions, but within the control plane lives an API server. This is the point of contact for any of those applications or services. Any internal or external request is going to go to the API server, and then the server determines if the request is valid and forwards that request if they have the right access. And also on the control plane is etcd. So this is really the memory for the brain, right? If the control plane is the brain, etcd is where the memories are stored. So this is a fault-tolerant, inherently distributed key-value store. It's a really critical component to Kubernetes, and it acts really as the ultimate source of truth for the cluster, and it stores cluster state, configuration, things like that. And then you see there scheduling, service discovery, load balancing, the things we talked about before. That's all on the control plane. And then you have the individual worker nodes, right? So a worker node in Kubernetes runs an application, it runs a service, and there are typically a bunch of worker nodes in a cluster. Adding new nodes is how you're scaling Kubernetes. And so within these individual nodes, you have a kubelet. And so this is a tiny application that lives on every worker node. And basically the kubelet is like the arm. So, if the control plane is the brain, it communicates, the kubelet does, with the control plane, and then it performs those requested actions on the worker node. So the control plane is the brain, the kubelet's like the arm. The control plane sends a command, and the kubelet executes that command. And then also, you have a container runtime engine. And that is a container runtime. This is what actually complies with the standards that are managed by the Open Container Initiative. We talked about the standard for these container images. This is the same initiative as far as the standards are concerned. And this is what's running the actual containerized application. It's the conduit between the portable container and the underlying Linux kernel. Well, what's missing here? A lot of stuff, right? We have portability, we have scalability, we have that automated policy-driven management, but this is not a complete solution, right? We haven't talked about networking. right? We don't know how to monitor the networking service. We don't have continuous integration, continuous delivery built into this, right? We don't have that tooling. We don't have application services. Where is storage? There's still a lot of work that needs to be done to set roles and access control. What about multi-tenancy? What about secure default settings? Kubernetes provides a lot of pluggable interfaces for a lot of these different tools and components, but this is not a complete solution, at least for the enterprise. And so why is this so hard, right? Networking, you can see right there, and I'm not sure if you can actually see my cursor here, but networking is a big part of this, right? And not even just networking, but monitoring is a big part of this as well. And so these are all things that don't exist just as part of Kubernetes. And if you look at this, this is one of my favorite slides that I get to present. This is a map of all the cloud native components that you need to choose from in order to run containers in production. So you see here the orchestration and management piece. Kubernetes is just a piece of this. This is just the scheduling and orchestration piece of it. We've talked about the infrastructure, right? That's a piece of this as well. You have to choose what infrastructure you're going to be running on. You need to choose potentially container runtime. What about CI/CD? What about API management? What platform are we running on here, right? This is a slide that updates weekly. This is quite honestly, this is a version of this from maybe 6-8 months ago. This thing is wild compared to what it is today. Is way more messy than what this is right now. So I highly encourage you to link there at the very bottom, github.com/cncf/landscape. Check it out. It's really, really interesting to take a look. But this doesn't include a lot of different things like infrastructure, application developer services, observability tools, right? And it gets bigger and more complicated every few weeks. Really, the takeaway is, Kubernetes done right is hard. Installing Kubernetes, playing around with it for most is not really an issue. Establishing Kubernetes as a platform for the enterprise takes a whole lot more than that, right? You could get started with Kubernetes. You can install it in probably 10 or 15 minutes, right? Really, really easy to do. But getting it ready for production to run business critical applications takes a lot more. And there are a number of things that need to be pieced together and tested and hardened. One example, identity management. You're going to be providing access to a lot of internal systems, to employees, to partners, to customers, and you have to adhere by the security rules that are established within the organization. And the way to do that with just identity management, with vanilla Kubernetes, well, first you need to write an integration between Kubernetes and your company's approved LDAP. So what do you need to be able to do that? Well, you probably need knowledge of DEX, which is an open source identity management system. You need knowledge of Kubernetes. You need knowledge of the integration systems to LDAP. And then you'll have to hook up Prometheus, which is an open source monitoring and alerting tool, or hook up some other monitoring system so you can actually get full visibility into all the different operations and testing in production. That's not feasible. Just for that one component, you're essentially having to hire somebody with knowledge of 4 or 5 different projects because likely you don't already have somebody like that employed in your own organization. So that's where OpenShift comes in. And I know we're coming up towards the top of the hour, so I will have to get through this a little bit more quickly. But no matter what architecture you choose for the application, what programming language the developers are developing in, OpenShift is providing a single and consistent development model across the build, test, deploy, and monitor review lifecycles. So think of OpenShift really as Kubernetes, where we have worked with each of those different components from that giant landscape chart from a few slides back, and we have built out tooling for each of these additional components, right? And so there's self-service infrastructure built in, right? We're allowing developers to provision what they need on demand. They don't have to open up a ticket with the infrastructure teams. We're providing that consistent environment and the automated build and deployment that Kubernetes has, but then we're also including things like continuous delivery pipelines, configuration management, right? Application logging and metrics, having that all concisely, aggregated into one place. And so really what OpenShift is enterprise Kubernetes, right? And so what you're seeing here within this chart, and I wish I'll have to go back and actually color code this, But on the orchestration side and the storage piece, that's all that Kubernetes really is. Every single other one of these pieces is something that OpenShift is bringing to the table. And these are things that, as just a vanilla Kubernetes running in production, you would have to, build out your own CI/CD pipeline and integrate that into Kubernetes. You would have to have working knowledge of networking and build integration with something like Open vSwitch into Kubernetes, whereas we provide that already built in and ready for you. So to answer that question that's in the chat, with Kubernetes, there's no need for separate network monitoring software. There 100% is, but with OpenShift, there is not. And so really this comes down to, I'm sure all very, very familiar with, our development model. We're the open source organization. And so, we work with all of these dozens and hundreds of open source projects, and we find the best ones that our customers need, and we integrate that functionality into our build of Kubernetes, which is what OpenShift Container Platform really is. And so with this foundation of a trusted enterprise Kubernetes platform, we're adding these productive enhancements to really deliver an application platform with all the components that our customers need that are fully integrated to build, deploy, and manage these containerized applications. And so we launched OpenShift 4 in May of 2019. And so we're right now, I think, just at the point where we've launched OpenShift 4.6. And so at this point, we made a lot of enhancements to the platform, and it's quite a mature version of the platform versus if you'd asked me, in June of 2019 with 4.0, there were still a lot of features that we were still building into the product, a lot of which are now available. And so one of the big features is integrating RHEL CoreOS, which is essentially a container flavor of RHEL, to really streamline the initial installation and the ongoing management of not just the underlying infrastructure, but of OpenShift itself. So what you're seeing on this slide, really everything above Red Hat Enterprise Linux Core OS, which is the underlying OS, everything above that is what's included inside of OpenShift. And so, we're trying to create value for both internal and external customers. And to do that, it all depends on the ability to develop and deliver applications more quickly. And so, we're now able to provide an application platform that provides a consistent way for both the developers and the operations teams to collaborate across all those deployment footprints, whether it be edge and air-gapped environments to on-prem or hybrid cloud deployments as well. Now, I talked about this a little bit early on. I won't spend too much time on this, but a lot of the different security policies, the checklist, things like that, that's a big concern for a lot of our customers. And the nice thing is that securing containers is a lot like securing any running process. And we think of security really across these three different categories. So you need to control the security of your containerized applications. So that's built-in functionality into OpenShift, but then you also need to secure and defend the actual container platform infrastructure and extend that security of the overall solution by leveraging tools from the broader security ecosystem. So, application security is something that is essentially a new skill, a net new skill set, and something that we provide from a training perspective. But the infrastructure security, those are all leveraging those same tools that Linux administrators should already have. We're also providing automated operations across the entire lifecycle. So not just an automated installation, which is really kind of an opinionated and immutable installation, but also all those day two operations that our customers need to be able to automate, whether it be integrating storage or networking. And then we also provide the option for our customers to, where they need to, have a mutable installation method, right? So they can still install OpenShift on top of just our traditional Red Hat Enterprise Linux and give them a way to install and manage those clusters of whatever the way their organization has sanctioned. So from there, we just have a couple more minutes. So I did want to transition into some training pieces as well. From a training perspective, as far as ways to train, we do offer multiple modalities for you and for your customers to get trained and potentially certified. Obviously, right now we're not really doing anything in person, but luckily we've been doing virtual training from an instructor-led perspective and from a self-paced perspective for several years at this point. And so although we would love to be on site with our customers delivering this training in person, we are able to do it effectively and safely from the comfort of your own homes. And so we do offer all of our curriculum either in a on-site fashion, or I should say virtual on-site fashion, instructor-led, and in a self-paced option as well, including access to individual courses for 90 days or to a learning subscription, which provides you access to our entire course portfolio for a full year. From a curriculum perspective, we have a lot of training, and this isn't even all of the OpenShift training that we have available, but really everything around getting started there at the very top, an introduction to containers, Kubernetes, and Red Hat OpenShift, getting experience with actually building containerized images, understanding how to deploy them and manage them at the Kubernetes level, and then also how to deploy them into OpenShift, really just as that first level of understanding. From there, depending on what you're going to be responsible for, our administration track really kind of tracks to that IT operations team, day one operations as far as actually installing, managing the cluster itself, to day two operations. It's really around scaling and GitOps workflows and implementing CI/CD pipeline. We have our DevSecOps track that really leapfrogs from that intro course really into just specifically securing the containers and securing the OpenShift platform. And then obviously on the development track, this is a brand new way of developing, at least on the tail end for these development teams. So, understanding considerations for building applications, containerizing existing applications, how do we build cloud native applications, net new greenfield application development, a lot of curriculum around, building out microservices as well, using technologies like Wildfire Swarm or Spring Boot or Quarkus or Service Mesh as well. So with that, I also wanted to mention this Introduction to OpenShift class, which is really kind of a one-day course, really a low prerequisite on-ramp to, for developers who are not really going to be accessing the cluster from the command line, just getting access to an OpenShift cluster from the web console and being able to have experience deploying and monitoring and troubleshooting an application very, very kind of high level. And then we do offer certification as well. For most of these courses, there is going to be some kind of certification available, and we do offer those certifications remotely for the most part. I would say the bulk of our OpenShift curriculum is now available for remote certification. So if you are interested in certification, we do have a lot of information on that through the Fierce website. I would encourage you to reach out to the Fierce team. With that, I know we're right at 1 o'clock, so I know I ate into our Q&A, but I'd be happy to stay on and answer any other questions there may be. Otherwise, we can go ahead and wrap up. And I don't see any other questions in the chat. I'll give it just a minute or so, and while we wait, I'll go ahead and thank the team at Fierce Software. They've been a great partner of ours, and we work with them a lot, and we will continue to provide these kind of webinars over over 2021 and get a little bit deeper into some of these different concepts around OpenShift or automation or building cloud native applications and things like that. So if you have questions around those kind of things, we'd love to hear them. It does look like we had another question come in. It's good that Kubernetes is most services bundled with one. It integrates with other services. When it comes to scalability, how does it compare to Nomad and HashiCorp? I don't know the answer to that, quite honestly. My experience really with HashiCorp is really with Vault primarily. So I would have to do a little bit of research on my end to see what that looks like. But unfortunately, I don't know the answer to that question, Arun. Doesn't look like we have any other questions coming through. Arun, I'll have to follow up with you on the answer to that. But as far as any other questions that you may have, don't hesitate to reach out to our team or to the team at Fierce, and we'll get any answers that you need. But with that, I want to thank everyone for your time. I apologize we didn't have enough time for Q&A, but I really appreciate you all attending today, and hope you have a great rest of the year and a great 2021. Thanks, everyone.
Thank you, John. Have a good one.